Function, if it is there, you have to use the complement. Why do you need complement? Whole dash. This will become x dash. X dash here is x into y dash into z dash. Finding out the canonical and the standard forms. What are canonical and standard forms? All the variables appear exactly once. Hello students. Welcome to the next session of Digital Electronics. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram College. In the last session, I stopped the session till the complement system, or how to find the Boolean functions, or how to minimize the Boolean functions, is it not? In the today's session, we shall continue something more, learn more about the Boolean functions. Okay, so Boolean functions, as you know, consists of the Boolean variables, is it not? Maybe A, B, C or X, Y, Z. Okay, we will have 6 variables in total, that is 3 normal variables and 3 complement variables. Like if you have x, y and z as the variables, you will be having complement variables as x dash, y dash and z dash, is it not? If you have a, b, c, then it will be a comma, b comma, c. Complement will be a dash comma, b dash comma, c dash, is it not? Okay, so we have these 6 variables. Okay, using these 6 variables and the operators is AND operator, OR operator and NOT operator. So we'll be using 3 operators, AND, OR and NOT, dot operator or multiplication, plus operator or addition performance or addition operation. We have NOT, complement of a value. Okay, using these 6 variables and 3 operators, we can create the Boolean functions, is it not? So we have Boolean functions combining the multiplication, addition and complement. Okay, in the last session, I just explained all those things. And how do you minimize? Why do you need to minimize the expressions, is it not? We shall move on to the next thing, that is the complement of a function. If we have a function f equals x, y, z, x plus y plus z, x into y into z, or x dash into y dash into z dash, or x dash plus y dash plus z dash, anything you can take. But the thing is, function, if it is there, you have to use the complement. Why do you need complement? If you have on button, what you need to have is off button also, is it not? So if you have a switch always contains on and off, both the conditions, is it not? It is not like button has only on condition or off condition. One switch can undergo 2 states, on and off, isn't it? Usually on will be normal function, off will be complement of that, reverse of that or inverse of that, is it not? That is why along with normal function in Boolean algebra, we need to study the complement of a function also. If you have 0, how do you generate 1? If you have on the switch, how do you off it? If you have off the switch, you should know how do you on the switch. Okay, all these things must be known to perform anything in a digital device, isn't it? If a system is in 0 state or off state, you must know how you can bring it to on state or 1. If your device is in low state, you must know how you have to bring that state to high. You have to know about that. That is what called as the complement. If you have 0, you must make it to 1. You must know how to make it to 1. If you have 1, you must know how to make it to 0. How do you find out the complement of a function? Okay. You can derive the complement of a function by interchanging the multiplication and the addition operator. You remember one thing, in all other subject, in the entire subject of digital electronics, we will deal with only 3 operations. That is multiplication, addition and the complement. That is not and operation, or operation and not operation. Using only these 3 basic functions, we can make all the devices work. Okay, how do they work will be the concept of next unit. Okay, you have to find out the complement of a function by interchanging the multiplication operation and the addition operation. And along with that operator, you have to interchange the operands also. Change the ones to zeros and zeros to ones. Okay, and you have to complement each variable using these 4 steps or these 2 steps, interchanging the operators and the operands. Okay. Another step you can take, another method to find complement is interchange ones and zeros in the truth table column showing f. F dash can be obtained by getting the complement of that. Okay, like if you have a function xy dash z, you have this function. How do you perform the complement is, if you take x, y, z, so the combination will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Other combinations is 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. You have 8 combination of zeros and ones. How do you perform this? F equals x into y dash z. How do you perform? Y dash will be, y dash if you take, it will be 1, 1, 0, 0, 1, 1, 0, 0. Isn't it? Y dash. How do you get the value truth table for function f is x into y dash into z. 0 into 1 into 0 will give you 0. 0 into 1 into 1 again 0. 0 into 0 into 0 again 0. 0 into 0 into again 0 into 0 into 1 is again 0. Next comes is the 1, 1, 0, again 0, 1, 1, 1, now it is 1, okay, 1, 0, 0, it is 0, 1, 0, 1, it is 0, okay. So, how do you find out the complement is f dash by complementing these values. So, it will be 1, 1, 1, 1, 1, 0, 1, 1. Okay. So, you have the truth table for complement. Either you can do it by interchanging the operators or by the truth table. Okay. You can get the function f dash by changing the state. If it is 0, you can change it to 1. If it is 1, you have to change it to 0. So, this will give you the complement, or you interchange. How do you interchange? F equals x, y dash, z. So, this will become, f dash will be, you have to interchange the operators. Now, we have dot operators. You have to do it plus. Interchange dot operator with plus, and variables will be you have to make the complement of the variables. X will be represented as x dash, y dash will be represented as y, and z dash, z will be represented as z dash. Okay, so complement of f will be x, y dash, z will become, when it is complement, it will become x dash y plus x dash plus y plus z dash. How do you do this? So I have easily complemented this. Is there any method to do this? Whether I'm doing it abruptly without any guidance or without any theorems or postulates, is you can make use of the one theorem to find out the complement. What is that? Is the De Morgan's theorem. You can use the De Morgan's theorem. What does the De Morgan's theorem will say is, if it is x plus y whole dash, if you make the complement of x plus y, it will interchange the values. X becomes x dash, y becomes y dash, plus will be interchanged to multiplication. In the same way, you have, if you have x into y and you want to find out the complement of x into y, you will get x dash, complement of y is y dash. Here you have multiplication operator, it will become plus operator, is it not? So these are the two De Morgan's theorem. Using this De Morgan's theorem, you can find out the complement of a function. When you check with this, x dash y z whole dash, if you consider this as b, b will be equal to y z, isn't it? So yz. If you use De Morgan's theorem for x dash, this will become x dash into b. So y into z, x dash into b. This will become x dash into b whole dash is equal to x double complement plus b dash. Okay, complement will be nullified. You will get x plus b is yz whole dash. Again applying De Morgan's theorem, you will get x plus y dash plus z dash. Okay, we can find the complement of a system by using the De Morgan's theorem. Okay, what you need to note down is complement of a system can also be derived by finding the function's dual. Okay, as I have said, duality in the theorems, and then complementing all of the literals. You can complement the literals. Okay, if it is x, you can make it x dash. If it is y dash, you can make it y. If it is z dash, you can make it z. Alright, so this is how you can find the complement. We shall look at some other example. How do you find out the complement? Okay, if you take another example, f equals, how do you find out? X plus y dash plus z into x dash plus y dash plus z. How do you find the complement of this function? Okay, here we have to find out the f dash. Again, we have to use the De Morgan's theorem. Okay, how do you use the De Morgan's theorem here? X plus y dash plus z will give you, again, what the simple method is, you interchange the operators and complement the variables. Okay, complementing is, here we have x, make it x dash, plus is there, you find out, you change it with multiplication, y dash is there. You can interchange with y. Plus is there. Dot operator. Z is there. You can make it z dash. Again we have the multiplication operator. Change it to plus. Again we have x dash. Make it x. Plus is there. Multiplication. Y dash is there. Make it y. Plus operator. Interchange it to multiplication. Z is there. Make it z dash. Okay, this will become f dash equals x dash into y into z dash plus x into y into z dash. Okay, another function you can give is f equals xy dash plus x plus y plus z. Now, function for this can be obtained like this. Complement f dash equals x dash plus y into x dash y z dash. So, you can interchange the operators and complement the variables. We will take another example. Okay, f equals, we will take another example. F equals x into y dash z plus, you can take the example f equals x into y dash z plus yz. How do you perform the complement of this system? F dash equals, you multiply it, x into y dash z plus x, y, z. Okay. So, this can be used to find the complement x dash plus y, x dash plus y plus z dash into, this plus will be converted to multiplication operator. Next we have x dash plus y dash plus z dash. Okay, it is as simple as that. Okay, or you can keep it as it is, f dash x dash plus y plus z dash into y dash plus z dash. You can also keep it like this. Okay, y plus z dash into y dash plus z dash. You can, both the things you can do. You can multiply it and you can then find the complement, or you can change the complement the variables x dash plus y plus z dash into y dash plus z dash. You have another example, that is f equals b into c dash plus a dash into d into a into b dash plus c into d dash. How do you find the complement of this function is, again the same method, interchange the operators and complement the variables. Okay, now this will be b becomes b dash, c becomes c, you have multiplication operator here, this will become plus. Okay, next here you have plus operator which will become multiplication into a dash will become a plus d will become d dash. Alright, next we will go to another expression, plus, here you have multiplication operator, this will become plus, a will become what? A dash plus B dash will become B. This plus operator will become multiplication operator. It will be C will be C dash plus D dash will be D. Okay. Final expression will be B dash plus C into A plus D dash into A dash plus B into C dash plus D. Okay. So this is the final expression. We will take another example. This is another example. F equals A into B whole dash into A into B dash into B. Alright. So how do you find out the complement for this? First we have to start with the outer brackets. Now it will be A into B whole dash. So this multiplication will be converted. So this will become whole dash plus A dash. This will be A into B dash whole dash, okay, plus B dash. Okay. Next is, again we have to simplify this one. Okay. This will become A dash. So both the complements will be nullified. Change the multiplication to plus and this will become A dash plus B dash plus A dash. Okay. Here it will be A dash plus B dash plus B dash. This will become A dash plus B dash. Here you have multiplication operator. This will become plus A dash plus B dash. Okay. Total will take A dash. If you simplify this, this will become A dash plus B dash. Alright. So this is another example. How do you find out the complement? Alright. Next we shall move on to the next concept, that is finding out the canonical and the standard forms. What are canonical and standard forms? Okay. The simplifications of the Boolean functions. Why do you need the simplification of Boolean functions? Is, as you know, these Boolean functions are the basis for the gates. Okay. As I said in the last session, Boolean functions are the basis for the gates. You can't have too long Boolean functions because it needs too much gates. The circuit will become too much complex. It will be difficult to solve it and it needs too much gates. So, too much gate means integrated circuit will become large in size and it will take much investment. So, to reduce investment and the IC's size, you have to reduce the number of gates that are used. How do you reduce the number of gates? Is by reducing or by simplifying the Boolean functions. As I said, Boolean functions are the basis for everything, isn't it? So for simplification, we use two forms. One is the canonical form, another one is the standard form. Okay, canonical form and the standard form. What are these? Okay, what are the conditions here is, identical functions will have exactly the same canonical form. So canonical form means a form of algebraic functions which contains all the basic variables. Like if you are using x, y, z, the function must contain all the variables of x, y, z. That is, you cannot miss a z or you cannot miss a y. In an expression, you need to have all the three variables, maybe in normal form or maybe in complement form. You need to have all the variables x, y and z. Okay. In this canonical and standard forms, we discuss about two terms. One is the min term and the max term. Okay. Min term and max term. What are these min term and max term? We'll discuss now. Next is sum of min terms, or you can say sum of products. Min terms are used to represent the products like f equals xy, z. So this can be termed as a min term. Okay. So min term, sum of min terms. Suppose if you take xyz plus x dash yz, this is a sum of two min terms. This one expression is called as a min term. So min term will be summed. This is one min term and this is another min term. Another min term. Again you can have x dash y z dash. This is another min term. You are making the summation of these min terms, which is called as the sum of min terms or sum of products. Okay. Next we have product of max terms. Max terms means, example, if you take f equals x plus y plus z. This is called as a max term. Okay. What this is called? Called as max term. Okay. Product of max terms, x plus y plus z. If you take x dash plus y dash plus z. So this is a max term. This is a max term. Again, if you have another one, x plus y dash plus z dash. Again, this is another max term. Okay. You are making the product of three max terms. This expression is called as product of max terms. Product of max terms and sum of min terms, or this can be called as SOP, sum of product, and this can be termed as product of sum. Okay. Product of sum, sum of product, or sum of min terms and product of max terms. Okay. And we'll be having in canonical form the product and the sum terms. Okay. We'll be having sum of products or products of sum. What are these? How do you generate these SOP and POS? We'll discuss in the next terms. Okay. So we should look at, before going to learn about how to generate the min term and the max term, our concentration is on knowing the basic definitions of these terms. These are new, isn't it? We don't know. We are newly introduced to these terms like sum term, min term, max term. What are these? Let's have a look at this. Okay. First thing is a literal, first term, a variable or its complement, or maybe x, y, z, a, b, c, x dash, y dash, z dash, a dash, b dash, z dash, d dash, or x, y, z, anything, w, x, y, z, anything you can take. Each variable or its complement, x and x dash, y and y dash, z and z dash, all these things will be termed as the literal. Okay. Next comes is the product term. Okay. Product term are connected by the dot operator. Okay. Whereas sum terms, in sum term, sum is plus, is it not? Sum term is connected by the plus operator. Next comes is the min term. Okay. In min term, What does the min term says here is, in the next concepts, we frequently make use of the word min term and max term. So remember what does this min term and max term is all about. Min term, okay, it is a product term. It is related to product term in which all the variables appear exactly once. So all the variables must appear in min term, either complemented or uncomplemented. So one example here you can take is f equals x, y, z can be termed as a min term. If you have f equals x dash y, I'll give the variables f of x comma y comma z will have the expression x y dash. This is not a min term because here the variable z is missing. When it will become a min term is when you have all the variables appear exactly once. All the variables must appear exactly once. Okay. Next is the max term, the complement of min term. It is a sum term in which all the variables appear exactly once. Same as the min term. In max term also, all the variables must appear exactly once, either in complemented form or in uncomplemented form. We shall take the expression f of x comma y comma z. That means the function has 3 literals. Okay. When you give the expression, if the expression is x dash z, this is not a max term. When it will become max term, f of x comma y comma z equals x dash y dash z. So this is a max term because it has all the variables or literals in its expression. Okay. So we have all the terms or all the variables in the expression. All right. So we have the examples. In the next session, I'm going to explain you how do you convert between the canonical forms. Along with that, how do you generate a canonical form? How do you convert and transform a non-canonical form to the canonical form? Okay. Thank you.